For more than 3 decades, one telescope has changed the way we see the universe. The Hubble Space Telescope has revealed the dark energy, mapped dark matter, and shown us galaxies millions of years in the past. But while it was busy up there in Earth orbit, something else was happening. For years, Hubble has been slowly losing altitude. And now, the telescope that once helped us understand space better could become a danger to Earth itself. Is there trouble with the Hubble? How long does it have left? And what happens when gravity finally wins? But before we go any further, if you enjoy exploring real science and space mysteries like this, you can subscribe to my channel now. And if you are someone who loves thinking a little deeper about progress and small changes, I've written a book called The Power of 1%. It's about how small improvements can slowly build something meaningful over time. Something that connects even with how we explore space step by step. So you can check it out on Amazon or Pothi if you are interested. Okay, then let's get started. For about 13 years, the Hubble has changed how we understand the universe. It orbits Earth at about 17,500 miles per hour, moving so fast. It circles the planet every 19 minutes, and since its launch in 1919, it has made more than 1.7 million observations of space. Before Hubble, scientists didn't even agree on the universe's age. Estimates range from 10 to 20 million years. Now, thanks to Hubble's observations, we know that the universe is more like 13.8 million years old. Plus, by watching certain stars and massive explosions, it helps scientists realize the universe is expanding and even uncover dark energy, the mysterious force that making space stretch faster and faster. But we talk more about this later. Right now, there is much more urgent question. Will Hubble threaten entire towns and cities once it nears the end of its life? So to begin with, most all good things eventually end, and that includes the Hubble Space Telescope. It was not built to orbit Earth forever. Even though it floats high above us, it still passes through the very edge of Earth's atmosphere, which by the way extends far beyond the Moon. Yep, the orbit of the Moon lies in the geocorona of our planet's atmosphere, on extremely thin cloud of hydrogen atoms and in Earth orbit. Well, it's kind of a track. Over time, it slows the telescope down, coming bit by bit closer to Earth, and eventually Hubble will be unable to stay in orbit and could crash back down to the planet. Over its long mission, astronauts help keep Hubble safe, doing spacewalks to fix it and upgrade it. They used the space shuttle's thrusters to nudge Hubble into a slightly higher orbit, thus pushing it away from Earth, which was just enough to slow down the effects of atmospheric drag. This way, the space telescope got a few extra years of life, but those spacewalks are no longer possible, and the original plan to bring Hubble back to Earth is gone too. The telescope was supposed to be retrieved by the space shuttle at the end of its mission, but nobody expected outlive the shuttle program. Now scientists are studying exactly where and how Hubble will finally come down and what risk it might pose when it does. Hubble's orbit is now slowly decaying. It means it will eventually fall back to Earth uncontrolled. The problem is the telescope was not designed to re-enter safely. Plus, solar activity like the sun's storms can also push Hubble's orbit, so making any prediction is super tricky. The study has found that, in the best case scenario, Hubble might stay in orbit until 2040, but in the worst case, it could start falling as early as 2029. The most likely scenario is 2033. If Hubble re-enters, some parts of it could survive the trip through the atmosphere, and this debris could spread along a path on the ground between 217 and 1997 miles long. Scientists can't say exactly where the pieces might land, but the overall risk to people is very small. For example, it's just 1 in 31,000. If the telescope falls in the most remote parts of the South Pacific Ocean, still even though the chance of people getting hurt is small, and the event is still years away, but NASA rules say that the risk is technically too high. For example, if Hubble falls back in 2033 along its usual orbit, the chance of a casualty is about 1 in 313. NASA's safety rules require the risk to be 1 in 10,000 or less, so Hubble doesn't meet that standard. The worst case scenario would be if debris landed in very crowded cities. If it hit Macau, 2 to 4 people could be injured or lost their lives. At least one person could be harmed if debris landed in Hong Kong or Singapore. So, to prevent problems, scientists want to do more detailed studies before Hubble finally comes down. This includes better predictions of the sun's activity and Earth's magnetic conditions, as well as updated maps of population in areas of risk. Even a telescope as famous as Hubble would have a tragic ending if it were to accidentally hunt people on its final fall to Earth. Now, speaking of Hubble telescope's success, one of the main reasons is its position high above Earth's atmosphere. From up there, it avoids problems that ground-based telescopes face. For example, gases like ozone block most ultraviolet light, so studying it from the ground is nearly impossible. But up there, easy. Hubble also doesn't have to deal with turbulent air, which is what makes stars twinkle. This lets Hubble take some of the sharpest and clearest images of the universe ever seen. When we look at Hubble's images, we always see the past. Light from stars and galaxies take time to travel to Earth. Even for nearby objects, this can be millions of years. For example, we observe the Andromeda galaxy, our closest neighbor, as it was almost 2.5 million years ago. Mind blowing, huh? So, in a way, telescopes like Hubble are like time machines, letting us study the history of the universe and see how galaxies and stars looked long ago. Hubble has a long track record. It helps scientists pin down the age of the universe, 13.8 million years, roughly 3 times older than Earth itself. Also, it discovered 2 moons of Pluto, Nix and Hydra, and revealed that nearly every major galaxy has a black hole as its center. It measured how fast the universe was expanding, giving us a more precise picture of cosmic history. And it was Hubble that mapped dark matter in 3D. It was the first ever map showing how dark matter is spread across the universe. Dark matter is a strange invisible type of matter that makes up most of the universe's mass, even though we can't see it or touch it. The map Hubble made shows that normal matter, mostly galaxies, trade to collect where dark matter is most dense. Instead of being spread evenly, dark matter forms a huge web-like structure made of long filaments. Over millions of years, these filaments have been growing and crossing each other, creating massive regions where galaxy clusters form. The map looks back almost halfway to the beginning of the universe and reveals how dark matter slowly became more clumsy as gravity pulled it together. Before this, scientists mostly rely on computer simulations to predict how dark matter should behave, and Hubble helped us directly observe its large-scale influence. And is crucial since by mapping dark matter across space and time, astronomers can better understand how galaxies form and group together. Plus, it may also help explain dark energy, the mysterious force that affects how matter in the universe moves and spreads out. All in all, Hubble has been a pioneer of the first detection of elements from the early universe, the first proof that supermassive black holes exist, and the first images showing black holes at the heart of the galaxies. It captured the first collision between astronomical objects, spotted oxygen in a moon's atmosphere, and even took the first image of a star's surface other than the sun. Also, it gave us first visual evidence of planetary building blocks, first exoplanet atmospheres, and even found organic molecules, in other words. It photographed asteroids with tiles, captured asteroids breaking apart, and detected water vapor plumes on Europa. Hubble saw the first predicted supernova, the farthest galaxy and star ever imagined at that time, and water vapor on an exoplanet in the habitable zone. It even snapped the first ultraviolet image of a forming exoplanet and spotted a possible moon orbiting an exoplanet. Through all this, Hubble gave us the first precise measurement of the universe's expansion rate and countless other discoveries. It may have cost millions, over 10 million in total, but its contributions are priceless. Hubble shown us the universe in ways we had never imagined. So that is for today. But if you like this video, just subscribe, like, share. Bye everyone!